Alright, so I've missed a few devlog Thursdays. Sorry about that. It's been 3 so far, which means about 3 weeks. And as you could probably assume, a lot has happened in 3 weeks. A lot. So I'll try and condense it. So let's start with week 1, the first devlog Thursday that I missed. I was planning on showing you the XE 2020, but at that time, just before, or actually on the day of that devlog Thursday, I discovered that it didn't work and came to the conclusion that I needed to start over. So I started over on a newer, faster XE 2020-1, still an 8-bit microprocessor, and I had it just about finished by the second week, the second devlog Thursday that I missed, but not quite. There were still some things that I needed to get finished, but by this last devlog Thursday, the one yesterday that I missed, I had it finished, and I had it ready to show. But also around that time, so for the duration of this week, I've been working on another thing, which you can see right here, that I'll get to in a minute. But first, the XE 2020-1. I'll go ahead and tell you about it. It's a much faster version of the XE 2020. However, it is not backward compatible in any way, shape, or form. That wasn't one of my priorities, because why make it backwards compatible with something that doesn't work? So anyway, I was also developing the Tic Tac Toe game alongside it, and so yeah, it's gotten mostly rewritten as I've gotten new instructions, and now both are finished. And I'll just go ahead and show it to you. It's set to run at a tick rate of 4.1 kilohertz, but it's not going to run that fast. I'm going to say maybe 1 to 2 kilohertz is how fast it's actually going to run, but let's find out. So if I do Control K to enable the ticks, we can see that it gives me a message, and it draws a tic-tac-toe grid, which is great. That's exactly what it's supposed to do. And it's got a keyboard, and I can... Also, yeah, you may have noticed... you have definitely noticed that there's no graphics, it's just a text terminal. That's because it's much faster and much easier to code for. Anyway, yeah, there's a keyboard, and I can put where I want to put my X. And the way you do that is it's capital letters, and the first letter is which row. T for top, M for middle, B for bottom. And then you type a column, L for left, M for middle, R for right. So if I do TL, it will put an X right there in the top left. And like I said, normally it runs a lot faster than this, but I'm recording, so it's a little bit slow. So now I can place player 2's O. And you may also notice that the joysticks are not being used for this in any way. I did try to use them at the beginning, but again, that was early on in the life cycle of both the game and the CPU, so I was having trouble getting it to work. So I just opted for this, and honestly, I'm glad that I made that decision. So where can I put player 2's O? I don't know. I'm just going to put it randomly because, it missed a T. Or I missed a T, actually. So, yeah, if you put in something that's not valid, it'll erase it. And if you put in a location that already has an X or an O in it, it won't accept that either, and it'll erase that too. But anyway, as I was saying, I'm just putting the O's wherever because I'm just going to make the X win to show you that the game works and it can successfully detect a win. Actually, no, I'm not going to try and win on my next turn. In fact, I'm going to prevent that. And I'm going to show you what happens when 3 or more of a certain piece is on the board. Like, for example, on X. So if I go to the bottom middle, then it'll go ahead and place all that stuff on there. And then you'll notice a long pause. Really long pause since it's running slowly. And what it's doing is it's checking to see if there's any win conditions. And I'm pretty sure I've refined the algorithm for checking to be basically as fast and as simple as possible. And it works. It took a lot of debugging, but yeah, it works perfectly. So now I can go ahead and place my X in the middle. Oh, wait, no, that's the O. Oops. Well, X isn't going to win now. Wait, no, there is still a chance, actually. So I'm just going to go ahead and do that. I'm actually not very good at tic-tac-toe. I mean, I don't know why. I'm just not. So yeah, now there's 3 of both, and that doesn't actually affect the speed of the algorithm. It's still, as long as there's 3 or more of one or the other or both, it'll check to see if there's a win, because a win is 3 in a row. And so now I can go ahead and put... Oh, no, that's the O. Also, you can backspace, too. So that would have to be middle right if I want X to win. It was an O, right? Yes, okay. Which now means it's gonna load. It's calculating. It's computing. Now I can go ahead and put my X right there in the bottom left, and I'll win once it finishes drawing and calculating. Let's give it some time. There we go. Player 1 wins. And yeah, I actually have played this Tic Tac Toe game with others before to test it, and that's when a lot of the problems showed up. I'm glad I did that, because, since I'm so bad at Tic Tac Toe, it gave me a lot of different edge cases that were checked, and showed me a lot of bugs that needed fixing. And now they're all ironed out, and it works perfectly. I now have an 8-bit Tic Tac Toe game that's text-based, and it's really cool. And, well, now is for this thing right here, which you can see has this little green light that's just blinking away. That is the XE2020B. At around the start of this week, and I think maybe a little bit before that, I was getting close to being done. In fact, I think I was almost practically done with the XE2020-1 and Tic Tac Toe, and I was thinking, you know what? I could do better. I could make it run faster, and if it was 16-bit, I could make it so much more efficient. And so I thought, you know what? I'll do that. And I did. I now have a 16-bit microprocessor, also text-based. I mean, I guess you could make it graphical-based, because there's a cool feature that I'm about to mention when I get to explaining it. So yeah, I have a 16-bit XE2020B right here. And I haven't gotten a chance to test it. I mean, I have tested it by manually inputting the bytes that it's reading and seeing how it responds to them and executes the instructions. And so far, it looks like every instruction works, but I just haven't gotten it hooked up to any memory with a lot of instructions in it yet, or hooked up to any peripherals. So again, not tested in the field, but pretty sure it's finished. So yeah, that means my next goal is to make Tic Tac Toe for the XE2020B. Now, to talk about some of its features. We don't need this running. That's completely unnecessary. So like I said, 16-bit CPU. And what does that mean? Well, the XE2020-1, that has an 8-bit operand. No, opcode. Well, yeah, operand and opcode. It's an 8-bit system. So yeah, the opcode is 8 bits, which means it could support up to 256 instructions. However, it actually only uses 64. And the reason it uses so many is because the XE2020-1 actually has a 16-bit ALU, so it needs a way to form 2-bit words out of 8-bit bytes. And so that's why there's a whole bunch of different instructions. There's instructions for manipulating single bytes and instructions for manipulating 2-byte words. However, the XE2020B being 16-bit, it has I said that so weirdly. It has much fewer instructions. It has, how many? I don't remember. Definitely less than 43, which is how many the XE2020, the original, had. In fact, I can just look at the XE2020B documentation right now and find out. It has, 2.1, that is, 2.0 is 48, so that's 49. So it has 50 instructions because 0 is an instruction. Oh, so that's more than 40. Okay, I was wrong. It has more than 43, but of course that's because, well, I think it's mostly because there's a lot more arithmetic instructions. Wait. No. My math is so wrong. 2 0 is 32. So that means there's 30. Okay, so that's be 32, 33. So yeah, 34 instructions, right? I'm just embarrassing myself today. So yes, 34 instructions. I'm gonna say that, and I'm just gonna shut up about that number of instructions for now. So yeah, 34 instructions. And where was I? That's OBS. That's not. There we go. Oh yeah, I was talking about its features. So yeah, it's a 16-bit CPU, which means it has 16-bit word size, 16-bit ALU, 16-bit address width too. So again, 64. Well, technically, actually, 128K of RAM, since the words are 2 bytes, and there's 64,536 words. That makes, again, obviously you've seen I'm not very good at math, so I'm just not even going to try that. It has double that in bytes. And also, another feature it has, which if I zoom in, is connected to this thing right here, is interrupts. And what interrupts are they're basically signals that tell the CPU, okay, whatever you're working on, you need to pause it because this needs your complete and undivided attention. And things that might need the CPU's complete and undivided attention are things like maybe keystrokes, mouse movements, other hardware peripherals whose changes need immediate response from the CPU, like just in case you may be stuck in an infinite loop, and you can use interrupts to get it out of that loop. And also, another thing that you could use interrupts for is having one or more coprocessors that intercept whatever the CPU is doing, and whenever they encounter something that is meant for themselves, they interrupt the CPU and go ahead and just do their own thing. Like, for example, currently the XE2020B lacks a block copy instruction. And that's because I just thought, well, since it supports interrupts now, I could probably make a dedicated block copy unit. And so that's what I'm probably going to do. And it would basically be intercepting the address lines and the data in and data out lines. And it'd also be connected to the interrupt lines. And this right here, this F, that's the instruction fetch line. That line is high whenever it's about to fetch an instruction. And actually, should it be high right now? If I reset it... Okay, yeah, it was... The line was on because it already run for several cycles. The first 12 cycles, it actually uses to get interrupt vectors. And what those are basically the locations of the different things that handle the different interrupts. Because the CPU doesn't handle them natively. The only native handling the CPU has of interrupts is to just reboot. So if you don't... If you have any interrupt vectors that are not defined, then it'll just reboot. And that may be acceptable for certain interrupts, but certainly not for all of them. You wouldn't want the CPU to reboot whenever you move a joystick. That would be incredibly stupid. But anyway, yeah, you could rig together something that's connected to the interrupt lines, the fetch line, the clock signal, and intercepts these things right here that could basically interface with the CPU like that. And an example of why you might need the instruction fetch line is so that the coprocessor can know what's an instruction and what's not. And whenever it sees an instruction that is meant for it, it interrupts the CPU, except it wouldn't be an interrupt that tells the CPU to do anything. It'd be an interrupt that tells the CPU to jump to some place where it just will loop and do nothing until, the block copy unit tells it, okay, go back to whatever you were doing. And yeah, and you could also technically make a graphics coprocessor that way. Something that could intercept graphics instructions and actually draw to an LED matrix if you wanted to do that. So yeah, I've tried to make the XE2020B as versatile as possible, and I think I've done it. And yeah, its assembly language is also considerably different, although still based on that of the XE2020-1. And again, I guess in the spirit of just... I don't know, it's not backwards compatible with the XE2020-1. Because why? Why would it be backwards compatible? I don't know, maybe because that would make my job a lot easier. would probably make porting, Tic Tac Toe to it a lot easier. But no, it's not backwards compatible in any way. So yeah, there's gonna have to be a completely separate assembler for the XE2020. I mean, there would have had to have been anyway since it's 16-bit. But yeah, I mean, it's kind of a mess right now. Having two CPUs at once that I'm working on both at the same time. Well, actually, I am now ready to devote my complete and undivided attention to the XE2020B, since, like I said, the XE2020-1 is finished. So I've been rambling for a long time, but anyway, the point is XE2020-1 is working. XE2020 never really worked in the first place. XE2020B, stay tuned for that. Hopefully we'll have a video about that soon. And thanks for watching. Bye.